Welcome to our Characterizing Network Infrastructure and Traffics Project presentation. Today, we will be exploring the unique aspects of each group member's internet connection and the fascinating world of network traffic. Let's dive in. Before we get into the technical details, let me introduce the members of our groups. Our groups consist of 5 peoples. Member A, Harun. Member B, Aina. Me as the member C. Member D is Nas. And finally, Amira as member E.
Today, I will present about characteristics of internet connection. First of all members A, B, C, D, and E share a reliable fiber internet connection with a consistent 300 Mbps capacity. Member A demonstrates impressive download and upload speeds, which is 233.88 Mbps and 151.74 Mbps, while member E stands out for exceptionally high download speed, which is 345.56 Mbps. Despite slight variations, all members enjoy low ping around 16 to 23 milliseconds, highlighting the overall efficiency and reliability of the fiber connections.
Now, let's take a moment to understand the language spoken by our devices. These languages are known as network protocols, and they enable seamless communication in the digital world. The first one is TCP, Transmission Control Protocol. Think of TCP as a diligent postman, ensuring that your messages or data packets reach their destination accurately and in the right order. It is like sending a registered letter that you will know it will get there and in the correct sequence. In our network data, TCP is the backbone guaranteeing reliable data transfer. The next one is HTTP, Hypertext Transfer Protocol. If TCP is the postman, HTTP is the language of web browsers. It is what allow us to view web pages, click on links, and navigate the vast landscape of the internet. When you open a website, your browser is using HTTP to fetch and display the content. The next one is DNS, or Domain Name System. DNS is like the translator of the internet. It takes human-friendly web addresses like www.google.com, for example, and translates them into machine-readable IP addresses like 192.168.1.1. This translation is crucial for our devices to locate and communicate with each other. The next one is Dynamic Host Configuration Protocol for IPv6, or we call it DHCP-v6. It is like a friendly host that assigns a unique IP address to device or on our network. This dynamic allocation ensures that each device gets a valid distinct address, facilitating smooth communication. It's like getting a name tag at a gathering. The next one is FTP, or File Transfer Protocol. FTP is the digital courier that facilitates the exchange of files over a network. Whether you are uploading a document to a server or downloading a file from the internet, FTP ensures a secure and organized transfer. It's like having a dedicated courier service for your digital files. The next one is UDP, User Datagram Protocol. Unlike TCP, UDP is a bit more laid back. It is the protocol of choice for real-time applications such as video streaming or online gaming. UDP doesn't guarantee the order of delivery of packets, but it excels in speed, making it ideal for time-sensitive activities. And finally, the ARP, or Address Resolution Protocol. ARP is like the phone book of our network, helping devices to find each other. It maps IP addresses to MAC addresses, ensuring that data packets reach the right destination within the local network. It is like making sure you are calling the correct person when you dial a number.
Next one, I'm going to analyze the number of packets captured in my Wireshark software. The first one is TCP, Transmission Control Protocol, which accounts 456,029 packets captured in the interval time. The next one is HTTP, Hypertext Transfer Protocol, which a total of 36,281 packets captured. The next one is Domain Name System. It is captured as a total of 1,552. The next one is DHCP v6. DHCP v6 is the abbreviation of Dynamic Host Configuration Protocol. It uses IPv6 address instead of the regular IPv4 address, which accounts 275 packets captured. The next one is File Transfer Protocol. It captured a total of 0 packets in the time of capturing. The next one is UDP, User Datagram Protocol, which is captured a total of 74,173. And the next one is ARP, Address Resolution Protocol, which is a total of 10,903 packets captured in the Wireshark software. All of those protocols are a total of 555,209 packets.
Based on this table, member B managed to capture 514,734 times of Transmission Control Protocol, 1,883 times of Hypertext Transfer Protocol, and 3,194 times of Domain Name System. Meanwhile, there is absence of Dynamic Host Configuration Protocol for IPv6 and File Transfer Protocol appears during the capture. There are 114,572 times occur for the User Datagram Protocol, ARP, that responsible for mapping IP address to MAC address was observed 762 times. In total, member B managed to capture a comprehensive dataset of 630,522 packets.
For member C, which is me, the Transmission Control Protocol, or TCP, the one that ensuring smooth data flow, made an appearance of 258,894 times in my network. For HTTP, the language of web pages popped up 365 times during my online adventures. For DNS, or Domain Name System, the translator making names understandable worked its magic 1,205 times. DHCP v6, the friendly host handing out addresses, seemed to take a break in my network, which is 0 times. For FTP, the digital courier had the day off too, which is 0 appearance. User Datagram Protocol, which is UDP, the messenger for real-time applications, appeared 91,278 times. Finally, for ARP, which is the introducer making devices recognize each other, made 40,347 introductions.
And now I will tell you guys about the number of times of this protocol have been appear for 1 hour. For 1 hour, I have set up Wireshark to listen to the network that is being used by my computer. Firstly, TCP have been appear for 243,000 times. Secondly, HTTP, which is have been appear for 400 times. Thirdly, DNS have been recorded for 2,000 times. Next, the DHCP v6 have been recorded for 1,000 times. Meanwhile, for FTP have been registered at 0 time. It because during 1 hour, I never has sent or transfer file from one host to another. Last but not least, UDP. UDP have been appeared for 234,000 times, and lastly, ARP is being recorded for 24,000 times.
For my part, which is for member E, I have captured about 599,474 packets of TCP, 15 packets of HTTP, 2,954 packets of DNS, 47 packets of DHCP-V6, and 0 packets for FTP. For UDP, I have captured about 69,714 packets, and lastly for ARP protocol, about 10,636 packets.
And today I'm going to explain the colors of the packets captured in my Wireshark software. The first one is black, which refers to bad packets. Bad packets represents packets that are filled with errors. For example, checksums are used to ensure the integrity of transmitted data. If the checksum calculated at the receiving end does not match the ones in the packet header, the packet is considered corrupt. The second one is color pitch, which refers to ARP, Address Resolution Protocol. It is usually used for many communications with another devices in the same local area network. And the third one is pink colored packets, which refers to the ICMP, Internet Control Message Protocol. ICMP messages such as a destination unreachable or time exceeded are generated by routers or hosts to provide information about network issues. When you encounter connectivity problems, network diagnostic tools may use ICMP messages to identify the source of the problem. Next one is red colored packets, which refers to the TCP reset protocol. Packet SCTP abort, TT low or unexpected. And red packets are usually marked as potentially dangerous packets. The next one is yellow colored packets, which refers to the SMB protocol, Server Message Block. Server Message Block is a network protocol used for sharing files, printers, and other resources between devices on a local network or over the internet. The next one is light green colored packets, which refers to HTTP, Hypertext Transfer Protocol. Is usually used when we are accessing World Wide Web, web application, and web server to receive and get the post and get request. The next one is light brown colored packets, which used for routing protocols. For example, CDP, Cisco Discovery Protocol, which is a proprietary protocol developed by Cisco to do the routing of the packets. The next one is dark gray colored protocol packets, which refers to the TCP synchronize and finish packet. TCP SYN flag is used to initiate a connection between two devices. Instead, the TCP FIN flag, which is short of finish, is to terminate an established connection between devices. The next one is light purple colored packets, which refers to the TCP traffic. TCP traffic refers to the data communication that occurs using the TCP protocol. And the last one is light blue colored protocol packets, which refers to the UDP traffic, User Datagram Protocol. Is one of the core protocols in the Internet Protocol Suite, providing a simple connectionless and low overhead method for transmitting data between devices on a network. For the next one, I am going to state the number of colors of entry that appeared in my Wireshark software. The first one is the color black, which is a total of 42,210. The next color is peach, which is a total of 10,903. The third color is pink color, which is a total of 5,509. The fourth color, which is red, 1,727. The next one is yellow color packets, which is a total of 1,129. The next one is light green, which accounts 1,600. The next one is light brown colored packets, which accounts 316 packets captured. And the next one is dark gray colored, 2,690 packets. And the second last is light purple color, which accounts for 456,029 packets captured. And the last one is light blue, which refers to the UDP, user datagram protocol, which accounts 74,173 packets captured in the Wireshark software.
For Table 2, which counts the number of each color of entry appears in member PCAP file, firstly, the black entries occurring 7,935 times represent various network anomalies and errors such as ICM errors and checksum errors. Peach-colored entries observed 762 times signify ARP packets, which crucial for mapping IP address to MAC address and facilitating communication within the local network. Pink entries accounting for 310 packets represent ICMP traffic that is commonly associated with ping request and response. Red-colored entries occurring 313 times indicate various events such as TCP reset. Yellow entries appearing 137 times represent SMB traffic. Light green entries occurring a remarkable 411,615 times denote HTTP traffic. This indicates extensive web-related activities such as accessing website and web services during the capture. Light brown entries observed 137 times represent routing-related activities. Dark grey entries appearing 4,165 times signify TCP synchronized and finished flags. Light purple entries occurring frequently represent general TCP traffic. The high count suggests a significant volume of communication using the TCP protocol, reflecting the importance of TCP in various network activities. Lastly, light blue entries slightly lower than UDP traffic represent UDP, user datagram protocol traffic, which is commonly used for connectionless communication.
Table 2 explains all the different colors that are being observed. The first one is black entries, which is critical issues. It caught my attention 17,263 times. The next one is peach entries, which is ARP. It happened 14,347 times. The next one is pink entries, ICMP. It occurred 274 times. In the red zone, I've got 285 entries. For yellow entries or SMB, shining with 1,886 times. For the light green entries, which is HTTP, I find 3,854 entries. And then the dark grey, which is TCP SYN/FIN, I find it 2,905 times. For light purple or TCP traffic, 258,864 times. And finally, light blue, which is UDP traffic, 91,278 times.
Now I will tell you guys about the number of each color that have been appear in my computer while I listen it using Wireshark. Firstly, for black color, it have appeared for 21,000 times. Secondly, peach, which is have been recorded for 24,000 times. Pink color for 17,000 times. Red for 500 times. Yellow for 4,900 times. For light green have been appear about 2,000. Light brown for 555 times. Dark grey have been appear for 7,000 times. Last but not least, light purple have been recorded for 243,000, and lastly for light blue is 234,000 times.
Lastly, for my PCAP file, which is member E, there are 2,374 black colors appeared, 10,636 for peach color, 2,310 for pink color, 372 for red, and for yellow color of entry, there are 790 for light green. It appeared in 54 lines, 236 light brown lines. For dark green, it appears about 4,332 times. For light purple, which is for TCP traffic entry, there is about 599,474 lines. And lastly, for light blue color, it appears about 69,714 times. For question E, which we need to provide 3 graphs or chart that represent the data that has been collected and analyzed. The first chart is a bar chart which indicates the number of times each protocol appears in each member PCAP file. We can see here, member E has the highest number of times for TCP protocol appeared. Member A has the most number of times appeared for HTTP protocol, while for DNS protocol, member B has the most number of times appeared. For DHCP v6 protocol, there are 2 members that did not capture any of it, which is member B and C. Comparing these protocols, FTP protocol displayed 0 data from all of the members since there is no file transferring occurred. Moreover, member D has the highest number of UDP protocol and also for ARP protocol. Next chart is a stack bar chart. This chart shows the number of each color of entry appears in each member's PCAP file. All of these colors indicate different type of information that had been presented just now by one of my group member, which is member A, Harun. Overall, member A has the highest number of black color entry appeared, while member D, Nazif, captured the most peach, yellow, and light green color entry. Member C, Amirul, captured the lowest number of pink and red entry, while member B, Aina, has the lowest number of light brown entry and the highest for light blue color entry. Lastly, for member E, Amira, she has the highest number of light purple entry. For the last chart, we choose to present a pie chart which represented the total number of packets captured by each member. Member A has captured about 20.2% of packets, which is 555,209 packets. Member B captured about 630,521 packets. Member C with the lowest number of captured packet, which is 13.3%. Member D with 18.8%, equivalent with 517171 packets. And member E with 24.8%, which is 682,374 packets.
Now, I will explain why different members of the group got different type of packet being sent and received. Firstly, it is because of the roles and function of each protocol in computer network. Each protocol has a specific purpose and it is based on the nature of the communication and the requirement of the application or services involved. For example, member A and member B got a different count of HTTP packets. It is because during 1 hour of listening to the network, member A is likely to do more browsing of website, downloading file or streaming media that can contribute to the frequency of HTTP packets than member B. For another example, you guys can see that member D has a higher count of UDP packets. UDP or User Datagram Protocol is known for its speed and connectionless nature where low latency is crucial. In other words, member D is likely engaged in real-time applications like online gaming, video conferencing or live streaming. However, based on the table at question C, you can see that every member has a 0 count at file transfer protocol. It is because the absent or low count of FTP packet might indicate that members of the group are not actively engaged in file transfer by using FTP. On the other hand, they might be using more modern and secure alternative for file sharing. Meanwhile, based on the table at question C, you guys can see that most of the members of the group have a higher count of TCP packet. The reason is that TCP is known for its reliability in ensuring error-free and order delivery of data. Members who are engaged in tasks requiring secure and sequential data transmission such as file transfer, web browsing or email communication may experience a higher count of TCP packets. In summary, the diversity in packet type can be attributed to the varied activity and application that different members of the group are involved in, each requiring specific network protocol to fulfill their respective communication needs. Now, I have finished answering question F. It means that we have finished present our video. So that's all from group 4. Thank you.